We are continuing with the model question paper discussion. Today, when the dates of the examination are also announced, the students preparing for such competitive examinations will be naturally very serious. They will be under tension. Physics ಓದಬೇಕಾ, chemistry ಓದಬೇಕಾ, maths biology ಯಾವ್ದು ಓದಬೇಕು. Each subject is voluminous. ಒಂದೊಂದರಲ್ಲೂ 15ರಿಂದ 20 ಚಾಪ್ಟರ್ ಇದೆ. ಯಾವುದಕ್ಕೆ ಪ್ರಿಪೇರ್ ಆಗೋದು, ಯಾವುದಕ್ಕೆ ಪ್ರಿಫರೆನ್ಸ್ ಕೊಡಬೇಕು, ಇದೆಲ್ಲ ಇಟ್ ಇಸ್ ಯೂಶುವಲಿ ಕನ್ಫ್ಯೂಷನ್ ಆಗ್ತಾ ಇರುತ್ತೆ. The best method is to go through several model question papers. That will give you an overall idea of the entire syllabus. ನಿಮಗೆ ಎಲ್ಲ ಚಾಪ್ಟರ್ಗೂ ಒಂದೊಂದು ಸ್ಯಾಂಪಲ್ ಬರ್ತಾ ಇರುತ್ತೆ. So, answering as many model question papers as possible at this crucial time where time is very precious is what is recommended by a large number of texts. So, we are also following the same thing. We are discussing a model question paper which prepares you for our state CET and NEET. It also gives a very good foundation for JEE also. So follow these questions with all seriousness. Have a notebook, have a pen or pencil, sit in a quiet area where your family members do not disturb you. I've been telling you that after the question appears on your screen, better pause it. Don't see for the answer that we discuss. You try to work on your own. At least a few steps in the right direction is of great help to you. You test your memory, what formula can be used for this particular question, like that. Then only you can verify with the way we have solved the question. That is a very nice idea. Okay, with this small introduction, we shall start the regular class of this session. We have come up to question number 15 out of 60. Today I am continuing with question number 16. Question number 16 has already appeared on your screen. Read it carefully. Which of the following molecules involve sp3d2 hybridisation? Look, I will tell you one easy method of easy and quick method of finding the type of hybridization involved in the formation of the given covalent molecule. Okay? Look, the method is you calculate the total number of valence electrons in the given molecule. For example, PF5. Phosphorus, as you know, it's a 15th group element, P block element. In P block element, number of valence electrons equals group number minus 10. That means phosphorus has 5 valence electrons. Phosphorus, nitrogen, arsenic, all these have 5 electrons in their outermost. Halogens, most of the students will be knowing 7 electrons in the valence shell. 7 into 5 is 35. Total is 40 valence electrons. Divide the number of valence electron by 8. You get the quotient 5. Now you just imagine which type of hybridization gives you 5 orbitals. Obviously it is D, S, P3, D1, S1, P3. But we have asked you sp3d2, sp3d2. Therefore, this is not the correct option. Next is IF7. Iodine is a halogen, 7 valence electrons. Fluorine is also a halogen, 7 into 7, 49, totally 56, divided by 8, quotient is 7. Now, hybridization which gives you 7 orbitals is S, P, 3, D, 3, 7, 3 plus 3 plus 1. So this is also not the correct option. Go to NF3. Nitrogen is 15th group element like phosphorus, 5 valence electrons, halogen 7 into 3, 21, totally 26, divided by 8, you get 3, quotient is 3. Whenever you get a remainder more than 1, you divide it by 2, not 8. If you divide the remainder by 2, the quotient will be 1. Totally it is 4. 4 orbitals means it is sp3 hybridization. Therefore, this is also not the answer. Last option should be the correct one. SF6. Sulfur is 16th group element like oxygen. 16 minus, also a p block element. 16 minus 10 gives you 6 valence electron. Again halogen. 7 into 46 is 42. Totally 48. Divide by 8. Quotient is 6. Obviously the one which gives you the 6 orbitals is S, P3, D2. 3 plus 2 plus 1. So, fourth one, that means option D was the correct answer for this question. Question number 17 has appeared in your screen. A fairly easy question, and it is a memory based question. Therefore, there are no principles as such involved. One hint I will give you for the 16th one. You think yourself A and B are Vanderwaal's constant. B unit remembering is very easy. B is the volume correction factor. B has got the same unit as that of volume. Either it can be liter, in SI unit meter cube. Liter per mole is the unit of B in liters, or it can be SI unit meter cube per mole. That is easy. The unit of B is easy to remember. Unit of A is slightly difficult. It is pressure correction factor. That means it should be expressed in atmosphere, bar, SI unit, Pascal, bar, etc. Its unit, the correct answer, yes. One hint I will give you. It contains mole to the power minus 2. Mole minus 2. Okay? Per mole the square. That hint you just remember. So it is option B, atmosphere, liter to the power minus 2, mole to the power of minus 2. In SI unit, instead of atmosphere, they may give you Pascal. Instead of liter minus 2, they may give meter cube to the power minus 2. Mole to the power of minus 2 remains the same. Now we have given you in this particular unit. So it is option B. This is a memory based question. Yes. Question number 18 has appeared on the screen. Read it carefully. You have been given delta H. You are asked to find delta G. Easy question, but a little brain twisting question. You have to think. There is some, see, here, general knowledge or what you say common sense to be applied in this particular question. Yes, most of you might have practiced such questions. Yes, you have been asked to find delta G. You very well know that delta G and delta H are related to each other by Gibbs equation. Yes, delta G equals delta H minus T into delta F. You have been given delta H as plus 100 joules. How do you know that it is plus 100 joules? We have not mentioned the sign in the question. They have said it is an endothermic reaction. Yes, you must be aware that endothermic reaction delta H is positive. You have not been given temperature nor change in entropy. How do you work out? In the question, you have not given temperature nor delta S value. In fact, we need both of these to calculate delta G, but it has not been given in the question. So that is the one where you have to think and exercise your common sense. Look here. In this equation, observe the reactants and products. X is a solid, Y is a gas, the product Z is also a gas. The entropy of a solid is to be taken as 0, it is negligible. X solid, Y gas, Z gas. Yes, the entropy of a solid should be taken as 0. Even a pure liquid also can be taken as 0. Yes, entropy do exist for reactants and products. Look, we have 1 mole of the gas on the left side, 1 mole of the gas on the right side. Therefore, their entropies are almost same, S1 equals S2. Because both are gases, number of moles are also same. It is not enough that they are gases, number of moles also should be same. Therefore, the entropies of Y and Z should be same. S1 should be equal to S2. Delta S of a reaction is given by entropy of the product minus entropy of the reactant. Product is S2, reactant is S1. Since both are same, delta S is 0. If delta S is 0, T into 0 is also 0. Therefore, delta G equals delta H. Therefore, delta G is plus 100 joules. Option B. Yes, here I will give you one more information. If delta G is positive, you know that the reaction is non-spontaneous. The option also could have been spontaneous, non-spontaneous, equilibrium, neither spontaneous nor non-spontaneous, like the concept. Yes, students, the next question has appeared on your screen. ಸರಿಯಾಗಿ ಓದ್ಕೊಳ್ಳಿ, ಸ್ವಲ್ಪ ನಿಧಾನವಾಗಿ ಓದ್ಕೊಳ್ಳಿ, ಪರವಾಗಿಲ್ಲ. ಸ್ವಲ್ಪ ಲೆಂತಿ ಕ್ವೆಶ್ಚನ್ ಇದೆ, ಬಟ್ see it can be worked out easily. Then, yes, look here. The equilibrium constant Kp of the reaction is given. Kp is partial pressure equilibrium constant. That is 4 per atmosphere at 1000 Kelvin. What would be the partial pressure of oxygen at equilibrium if equilibrium amount of SO2 and SO3 are same? Andre, the concentration of SO2 and SO3 amounts andre moles anta tilkobeku. The number of moles of SO2 and SO3 are the same. Amount andre mole anta. Naan work ಮಾಡ್ತೀನಿ, just observe. This is the equation given. 2SO2 gaseous plus 1 O2 gaseous reversible 2SO3 gaseous. Kp ಬರೀರಿ. Kp ಬರಿಬೇಕಾದ್ರೆ partial pressure ಬರಿಬೇಕು. Partial pressure of SO3 the square divided by partial pressure of SO2 the square. Square ಯಾಕೆ? Because the stoichiometric coefficient is 1 into partial pressure of oxygen. One data is there in the question given. Amount of SO3 and SO2 are same. Amounts same andre number of moles are same. Partial pressures are same. Therefore, they get cancelled. When the moles are same, their partial pressures are also same. Kp is given as 4 per atmosphere because 1 over P of O2. Therefore, P of O2 equals 1 by 4 means 0.25 atmospheres. So, option B is the correct choice. Next question has appeared on the screen. Read it. ನಾಲ್ಕು ನಿಮಗೆ ಈ ಈಕ್ವೇಶನ್ ಕೊಟ್ಟಿದ್ದೀವಿ. ನಾಲ್ಕು ಈಕ್ವೇಶನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಅದರಲ್ಲಿ ರೆಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ಯಾವುದು? ರೆಡಾಕ್ಸ್ ರಿಯಾಕ್ಷನ್ ಅಂದ್ರೆ ಏನು? ಜ್ಞಾಪಿಸ್ಕೊಳ್ಳಿ. Among the reactants, one of the reactant is oxidized, another is reduced. ಯಾವುದಾದ್ರು ಒಂದು ಆಕ್ಸಿಡೈಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿರಬೇಕು, ಇನ್ನೊಂದು ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಆಗಿರಬೇಕು. ಈಗ ಇದರಲ್ಲಿ ಫಸ್ಟ್ ಈಕ್ವೇಶನ್ Na ಲೆಫ್ಟ್ ಸೈಡ್ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಎಷ್ಟಪ್ಪ? ಆಲ್ಕಲಿ ಮೆಟಲ್ಸ್, ಎಲ್ಲಾ ಆಲ್ಕಲಿ ಮೆಟಲ್ಸ್ಗೂ +1. Most of the halogen compounds ಅಲ್ಲಿ halogen ಗೆ -1. Na is +1, right side ಅಲ್ಲೂ ಒಂದೇ Na +1. Cl -1, right side ಅಲ್ಲೂ Cl -1. K +1, right side ಅಲ್ಲೂ K +1. NO3, what is the charge on NO3? -1. -1. So, in the option A, there is no change in oxidation number for any element. All elements guno left side alli estideyo, right side allu ashte ide. Whenever there is no change in oxidation number in a reaction, it is not a redox reaction. ಒಂದಕ್ಕೆ ಕಡಿಮೆ ಆಗಬೇಕು, ಇನ್ನೊಂದಕ್ಕೆ ಜಾಸ್ತಿ. ಎರಡನೇ ಈಕ್ವೇಶನ್ ಅಲ್ಲಿ ನೋಡಿ, ಕ್ಯಾಲ್ಸಿಯಂ, what is the charge carried by calcium? +2. ಎರಡು ಕಡೆನೂ ಕ್ಯಾಲ್ಸಿಯಂ ಇದೆ, ಒಂದೊಂದೇ +2 ಅಂದ್ರೆ ಕ್ಯಾಲ್ಸಿಯಂದು ಚೇಂಜ್ ಆಗಿಲ್ಲ. ಗೊತ್ತಿಲ್ಲದೆ ಇದ್ರೆ ಬರ್ಕೊಳ್ಳಿ, C2O4 2- is called oxalate ion. ಅದರ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಇಲ್ಲೇ ಇದೆ. ದಿ ಚಾರ್ಜ್ ಕ್ಯಾರಿಡ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಸ್ ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್. ಎರಡು ಕಡೆನೂ C2O4 ಇದೆ, -2 -2. ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ H ಗೆ ಎಷ್ಟು? +1. ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಗೆ +1, Cl ಗೆ -1. No change in oxidation number in the second option also. Third option ಅಲ್ಲಿ ನೋಡಿ, zinc ಗೆ oxidation number 0 ಇದೆ. ಜ್ಞಾಪಕ ಇಟ್ಕೊಳ್ಳಿ, the oxidation number of any element in the uncombined state is 0. oxidation number ಬರೋದು ಒಂದು ಎಲಿಮೆಂಟ್ ಗೆ ಕಾಂಪೌಂಡ್ ಅಲ್ಲಿ ಮಾತ್ರ, ಅನ್ಕಂಬೈನ್ಡ್ ಸ್ಟೇಟ್ ಅಲ್ಲಿ 0. ಅದೇ ಜಿಂಕ್ ಗೆ ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ ZnCN ಟ್ವೈಸ್ ಅಂದ್ರೆ Zn2 plus 2Cn minus. So oxidation number of zinc has increased from 0 to 2+. Andre zinc is oxidized in this reaction. Ag note, Ag ಗೆ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ AgCl ಅಂದ್ರೆ Ag plus Cl minus. ಸಿಲ್ವರ್ ಗೆ ಎಷ್ಟು ಆಕ್ಸಿಡೇಷನ್ ನಂಬರ್ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ +1. ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ Ag ಮಾತ್ರ ಇದೆ, ಅನ್ಕಂಬೈನ್ಡ್ ಸ್ಟೇಟ್ ಆಗಿರೋದ್ರಿಂದ 0. ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಎಷ್ಟಿದೆ? +1. Right side ಅಲ್ಲಿ 0 ಇದೆ. ಅಂದ್ರೆ oxidation number of silver is reduced. Therefore, silver is reduced. Zinc is oxidized. This is a redox reaction. Zinc ಗೆ oxidation number increase ಆಗಿದೆ. 0 ಇದ್ದಿದ್ದು +2. Silver ಗೆ oxidation number ಕಡಿಮೆ ಆಗಿದೆ. ಎಲ್ಲಿಂದ? +1 ಇಂದ 0. So, this is a redox reaction. ನಾಲ್ಕನೇ ನೀವೇನೆ ಟ್ರೈ ಮಾಡಿ. ಅಲ್ಲೂ ಅಷ್ಟೇನೆ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ಗೂ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ OH ಗೆ -1, NH4 ಗೆ +1, Cl ಗೆ -1. ಚಾರ್ಜ್ ಕ್ಯಾರಿಡ್ ಬೈ ದ ion itself is oxidation number. ಅಲ್ಲೂ ಯಾವುದು ಚೇಂಜ್ ಆಗಿಲ್ಲ. So the redox reaction was option C. What is to be remembered? The oxidation number of an element in the uncombined state is 0. We are coming to the next question. Which of the following is electron precise reaction? Which of the following is an electron precise hydride? ನೋಡಿ ಯೋಚನೆ ಮಾಡಿ ನೀವೇನೆ. ಪ್ರಿಸೈಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಪ್ರಿಸೈಸ್ ಹೈಡ್ರೈಡ್ ಅಂದ್ರೆ ಯಾವುದರಲ್ಲಿ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಜಾಸ್ತಿನೂ ಇಲ್ಲ ಕಡಿಮೆನೂ ಇಲ್ಲ, ಜಸ್ಟ್ ಎನಫ್ ಟು ಫಾರ್ಮ್ ದಿಸ್ ಹೈಡ್ರೈಡ್. ಹೈಡ್ರೈಡ್ ಅಂದ್ರೇನು? ದಿ ಕಾಂಪೌಂಡ್ ಆಫ್ ದ ಗಿವನ್ ಎಲಿಮೆಂಟ್ ವಿತ್ ಹೈಡ್ರೋಜನ್ ಇಸ್ ಕಾಲ್ಡ್ ಹೈಡ್ರೈಡ್. ಮೊದಲನೇದು ಹೈಡ್ರೈಡ್ ಆಫ್ ಬೋರಾನ್, ಹೈಡ್ರೈಡ್ ಆಫ್ ನೈಟ್ರೋಜನ್, hydride of oxygen, hydride of carbon. ಇವು ನಾಲ್ಕರಲ್ಲಿ B2H6 ನೋಡಿದ ತಕ್ಷಣ ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಬೋರಾನ್ ಕಾಂಪೌಂಡ್ಸ್ ಆರ್ ಮೋಸ್ಟ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಡಿಫಿಷಿಯಂಟ್ ಕಾಂಪೌಂಡ್ಸ್. ದೇ ಆರ್ ಕಾಲ್ಡ್ ಲೂಯಿಸ್ ಆಸಿಡ್ಸ್. ಗೊತ್ತಿಲ್ಲದೆ ಇದ್ರೆ ನೋಟ್ ಮಾಡ್ಕೋಬೇಕು. B2H6, BF3, BCl3 etc. are electron deficient compounds. They are Lewis acids. ಆದ್ರಿಂದ ಅದು ಆನ್ಸರ್ ಆಗಲ್ಲ. ಪ್ರಿಸೈಸ್ ಅಂದ್ರೆ ಆ ಹೈಡ್ರೈಡ್ ಫಾರ್ಮ್ ಮಾಡೋಕ್ಕೆ ಎಷ್ಟು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಬೇಕೋ ಅಷ್ಟು ಕರೆಕ್ಟ್ ಆಗಿರಬೇಕು. ಕಮ್ಮಿನೂ ಇರಬಾರ್ದು, ಜಾಸ್ತಿ ಇರಬೇಕು. NH3 ನಲ್ಲಿ ನಿಮಗೆ ಗೊತ್ತಿದೆ ನೈಟ್ರೋಜನ್ ಹತ್ರ 5 ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. It has used only 3 electrons to form ammonia. 2 electrons are left unused. It is an electron excess compound. It has 1 lone pair electrons. Therefore, it is a Lewis base. Andre it is electron deficient compound ಆಗಿತ್ತು B2H6. Ammonia is an electron rich compound. ನಮ್ಗೆ ಆ ಥರದ್ದು ಬೇಡ. ಪ್ರಿಸೈಸ್ ಎಷ್ಟು ಬೇಕೋ ಅಷ್ಟೇ. H2O ನೋಡಿ, ಆಕ್ಸಿಜನ್ ಅಲ್ಲಿ 6 ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. 6 ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತೆ. ವಾಟರ್ ನಲ್ಲಿ it has used only 2. It has 2 lone pair electrons, unused electrons. So water is also an electron rich compound. It is Lewis base. ಅದಲ್ಲ ಅದು ಆನ್ಸರ್ ಅಲ್ಲ. CH4 ಅಲ್ಲಿ ಕರೆಕ್ಟ್ ಆಗಿ ಕಾರ್ಬನ್ ಅಲ್ಲಿ 4 ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದೆ. CH4 ಫಾರ್ಮ್ ಮಾಡಬೇಕಾದ್ರೆ ಕರೆಕ್ಟ್ ಆಗಿ ನಮಗೆ 4 ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಬೇಕಾಗಿತ್ತು. That is the hydride we were searching for. It is the electron precise hydride. That means the central atom has got as many valence electrons as required for the formation of the hydride. It has neither excess electrons nor electron deficiency. Adrinda option D was the electron precise hydride. Hopefully next question. Question number 22 has appeared on the screen. When sodium burns in excess of air, the compound formed is ಅಂತ ಕೇಳ್ತಾರೆ. ಈಗ ನಿಮಗೆ ಫಸ್ಟ್ PUC ನಲ್ಲಿ ಎಸ್ ಬ್ಲಾಕ್ ಎಲಿಮೆಂಟ್ಸ್ ನಲ್ಲಿ ಆಲ್ಕಲಿ ಮೆಟಲ್ಸ್ ನ ಪಾಠ ಮಾಡಿರ್ತೀವಿ. ಯಾವ್ಯಾವ ಆಲ್ಕಲಿ ಮೆಟಲ್ಸು? ಲಿಥಿಯಂ, ಸೋಡಿಯಂ, ಪೊಟ್ಯಾಷಿಯಂ, ರುಬಿಡಿಯಂ, ಫ್ರಾನ್ಷಿಯಂ ಅಲ್ವಾ? ಈ ಆಲ್ಕಲಿ ಮೆಟಲ್ಸ್ ನಲ್ಲಿ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ ಯಾವುದೇ ಗ್ರೂಪ್ ಆಗಲಿ, ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ಗೆ ಸ್ವಲ್ಪ ತನ್ನದೇ ಆದಂತ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ ಇರುತ್ತೆ. ಇಟ್ ಬಿಹೇವ್ಸ್ ಇನ್ ಎ ಲಿಟಲ್ ಪೆಕ್ಯೂಲಿಯರ್ ವೇ ಕಂಪೇರ್ ಟು ಅದರ್ ಎಲಿಮೆಂಟ್ಸ್ ಆಫ್ ದಿ ಗ್ರೂಪ್. ಲಿಥಿಯಂ ಇದೆಯಲ್ಲ, ಈ ಎಲ್ಲಾ ಆಲ್ಕಲಿ ಮೆಟಲ್ಸ್ನು ಬರ್ನ್ ಮಾಡಿದ್ರೆ ಏರಲ್ಲಿ they give corresponding oxides. Lithium gives lithium oxide, sodium gives sodium oxide, potassium gives potassium oxide, like that. But sodium oxide is capable of forming sodium peroxide also, but lithium won't. Sodium peroxide, H2O2, hydrogen peroxide, Na2O2, sodium peroxide. When sodium burns in air, mostly we get sodium peroxide. First sodium oxide bರುತ್ತೆ, it becomes sodium peroxide. Potassium ಅಲ್ಲಿ ಇನ್ನೂ ಮುಂದೆ ಹೋಗುತ್ತೆ, KO2 ಅನ್ನೋ ಒಂದು ಕಾಂಪೌಂಡ್ ಬರುತ್ತೆ. ಇದಕ್ಕೆ ಸೂಪರ್ ಆಕ್ಸೈಡ್ ಆಫ್ ಪೊಟ್ಯಾಷಿಯಂ ಅಂತ ಕರೀತಾರೆ. As you go down and down, more and more oxygen combines with the alkali metal. Lithium ಅಲ್ಲಿ ಒಂದೇ ಆಕ್ಸೈಡ್, Li2O. Sodium ಅಲ್ಲಿ Na2O, Na2O2. Potassium ಅಲ್ಲಿ K2O and KO2. Potassium superoxide. Now ಕೇಳಿದ್ರಲ್ಲಿ sodium, when sodium burns in air, we get sodium peroxide, Na2O2.